In this lesson we're going to solve some applications involving exponential equations, and earlier in the unit we solved some applications involving compound interest, and in those problems we were asked to find the principal, sometimes we were asked to find the amount. What we were not asked to find is time, and that's because we didn't have the tools to get at that variable that's up in the exponent. Now that we have studied logarithms, we can solve this type of problem. So example 3 asks, how long will it take $25,000 to grow to $100,000 at a 4% annual interest rate compounded monthly? So let's first write down the formula for compound interest, which is A equals P times 1 plus R over N to the NT. And so our amount is how much we want after time, which is the $100,000. The principal is our investment, $25,000. The interest rate as a decimal is 0.04. N is the number of times compounded. Since this is monthly, it's 12. And T is our unknown. So when I substitute in, I'm going to get 100,000 equals 25,000 times 1 plus 0.04 divided by 12 to the 12t. So my job is to isolate the exponential expression. So I need to isolate this right here first, and I will do that by dividing both sides by 25,000. That will give me 4 is equal to 4 is equal to 1 plus 0.04 divided by 12 to the 12t. Now, in order to get the variable out from that exponent, we use a tool, we use the logarithm. So we're going to take the natural log of 4, and we're going to take the natural log of the right-hand side also. What that allows us to do is to bring that 12t down as a factor. So we're going to have the natural log of 4 is equal to 12t times 1 plus 0.04 divided by 12. Now generally before I put values in my calculator, I'd like to simplify as much as possible, but without rounding. And so what I'm going to do is check to see if this 0.04 divided by 12 actually is a terminating decimal. If it is, I'll simplify before typing in my calculator. If it's not, I'm going to have to wait until the end of the problem to round. So it's a repeating decimal, so you do not want to round in the middle of a problem. So what we'll do is we'll wait. If that was something like a half and as a decimal value, that would be 0.5. That would be perfectly fine to turn that into a decimal right here. So let's finish solving this. In order to solve for t, I've got to divide both sides by 12 and by 1 plus 0.04 divided by 12. So what that gives us, it gives us the natural log of 4 divided by 12 times 1 plus 0.04 divided by 12 is equal to t. This is considered the exact value. I want to approximate that, and let's approximate that to the nearest tenth. And we're looking for time, and this will be in years. So we'll open up our calculator. And we do have to be careful with parentheses here. If you notice, we're dividing by this whole expression. We want to make sure that whole expression is in parentheses. So we're going to take the natural log of 4 divided by, and then I'm going to open parentheses, 12 times the natural log. Now we've got another set of parentheses for the log, so plus 0.04 divided by 12. Now, since I've opened two sets of parentheses, I have to close two. I'm closing the argument, and now I'm closing the denominator. If you get a syntax error, usually that's one of the issues, that you've just got an open set of parentheses that's missing a close. we're going to get t is approximately equal to 34.7 years. Okay, well that actually was the equivalent of quadrupling our money. Let's look at an example of doubling an investment. So the question is, how long will it take to double an investment of $2,000 at 6.25 interest in an account that compounds continuously? So this is a continuously compounding problem. We're going to use the formula A equals PE to the RT. And we know we want to double our investment, and $2,000 is our principal. So what that means is if I invest $2,000, to double that means I would have $4,000 at the end of a certain amount of time. E to the R, which is 0.0625 t. Again, I've got to isolate my exponential expression, so I want to isolate this. I would divide both sides by 2,000. So I end up getting 2 equals e to the 0.0625 t. If I take the natural log of each side, I'm going to get, remember, the natural log of e to any power is just that power. So I get the natural log of 2 is equal to 0.0625. Dividing both sides by 0.0625, I get t is equal to the natural log of 2 divided by 0.0625. Let's evaluate that on the calculator. Take the natural log of 2 divided by 0.0625. Hit enter. It's approximately equal to 11 years. Back up. So in this case, I guess the question from here would be, does it matter how much money I invest? How long is it going to take to double that money? So take out a piece of scrap paper before you do the practice problems down here. Take out a piece of scrap paper and just choose a value. Choose any value that you want. How much money do you want to invest? Double the money and solve the problem and see what you get for your time. How long is it going to take to double your money? Then start the video again, and we'll talk about a little trick and a shortcut to doubling money and even tripling your money. Okay, I chose to see how long it would take me to double, say, $5,000 at the same amount. So if I start with $5,000, I'm going to have A equals P E to the RT. If I start with $5,000, then to double my money I would have $10,000. E to the 0.0625 t. Dividing both sides by 5,000 gives me 2 equals e to the 0.0625 t. So you can see here the equation is exactly the same as last time when I take the natural log of both sides. Right. That the natural log of e to any power is going to be that power. I get the natural log of 2 equals 0.0625 t. Divide both sides by 0.0625. And t is going to be approximately equal to 11 years. So in general, if I want to double my money, it's just going to be 2 equals e to whatever your interest rate is, e to the RT. If I want to triple my money, so in this case it came out to be 2 equals e to the 0.0625t. If I wanted to triple my money, it would be 3 equals e to the 0.0625t, and I'd solve it from there. So whatever your interest rate is. Now in the end, the shortcut here for doubling or tripling your money is that if you're doubling, you end up, the amount of time it takes is the natural log of 2 over your interest rate. If you're tripling, it would be the natural log of 3 over your interest rate. So keep in mind that you certainly can do this out the long way. You're going to get the right answer. But when it comes to doubling and tripling, if you learn this little shortcut, it's kind of a nice way to get through a problem. And so when you do the practice problems, you can use the shortcut if you like.